Hello and welcome to this session. This session is all about the special topics in complex numbers under Engineering Math for EE. So let's start. The first topic is all about the De Moivre's theorem. It is said to be an important theorem in complex numbers, which was named after a French mathematician who is Abraham De Moivre, which lives noong 1667 up to 1754. Now, this theorem says that, let's say you have a complex number which is a plus bi raised to n. This can be simplified using the polar form of the complex number. So, a plus bi is said to be our rectangular form, then its polar form is r at angle theta. Then syempre, parehas silang naka-raise sa n. Now, we are going to simplify this equation by si r naka-raise kay n, then si theta will be multiplied to n. So, kahit gaano kalaki yung value ni n, this can be simplified using this theorem. And this theorem will use this formula, which is r raised to n at angle n theta. But taking note that syempre, instead of having rectangular form, you will be having polar form kasi convert nga natin siya into polar form. Then, your theta, since naka-polar form tayo, this is in degrees. So, there's an instance or cases na yung theta mo, since we are talking about Cartesian coordinates, ang maximum angle natin must be positive 360. So, kapag lumagpas ng 360, pwede natin siyang i-simplified. Then, sa calculator, kapag ginamit natin yung complex mode ng calcu, ang angle niya in polar form must be always less than 180. So, alam natin na ang maximum angle ng degrees must be 180. So, it has two sides. It has two rotations rather. It can be positive or negative 180 maximum. So, positive yung angle natin if from the positive x-axis, the rotation of your angle is counterclockwise. Then, negative naman yung angle natin if the rotation of the angle from the positive x-axis is clockwise. So, ang tagpo niyan lagi ay nakay 180 degrees. So, let's have an example. So, let's say we have to evaluate the given complex numbers, which is number 1, the quantity of 1 plus i. 1 plus i is considered a complex number, then raised to 18. So, ang gagawin natin, we have to convert 1 plus i sa polar form. So, para makuha natin yung polar form, we have to get the value of the r. Ang value ni r is the square root of 1 squared, then plus 1 squared, then evaluating that, you will now have the value of r as equal to the square root of 2. Then after getting your r, we will get the theta, which is the arctan of b over a, wherein arctan of 1 over 1. So since arctan of 1 is simply 45 degrees. So gagamitin natin yung De Moivre's theorem. But first, the location of your theta is first quadrant. So, ang equivalent angle niya sa polar form is yun pa din. So, the polar form of 1 plus I is square root of 2 at angle 45 degrees. So, gamit yung De Moivre's theorem, let's say this is your z. That is raised to 18. So, square root of 2 at angle 45 raised to 18, i-apply natin ngayon yung De Moivre's theorem. This is r, then this is your theta. Si r, i-raise natin kay n, tapos si theta, i-multiply natin kay n. So we will now have z raised to 18 equivalent to the square root of 2 raised to 18 at angle 18 multiplied to 45. So if we evaluate that equation, magkakaroon tayo ngayon ng 2 raised to 9 since 18 over 2 is 9. Then 18 multiplied by 45 is 810. Ito yung sinasabi ko kanina na lalagpas siya ng 360. But our rule must be it's either lower than positive or negative 180 degrees. So we have to simplify the 810 degrees angle. So we will have twice ng 360. So that is 720. Ima-minus ngayon natin sa 810. So ang matitirang angle natin is 90 degrees. So that's positive. So therefore, yung R natin, which is 2 raised to 9, that is 512 equivalent. So instead of using 2 raised to 9 angle 810 degrees, the z raised to 18 is equal to 512 at angle 90 degrees. That is in polar form. But if we will have the rectangular form of the 512 angle 90 degrees is equivalent to 512 I. So next example, let's say we have the quantity of 2 minus I raised to 10. Then getting the polar form of 2 minus I, you will have the value of R as the square root of 2 squared plus the negative 1 squared, which is equivalent to the square root of 5. Then the theta is equivalent to the arctan of negative 1 over 2, which is negative 26.57. And the location of your negative 26.57 is fourth quadrant. So the equivalent polar form of 2 minus I is the square root of 5 at angle negative 26.57. So gagamitin na natin ngayon si de MOIVRE'S theorem, which is si z natin, which is raised to 10, that is equivalent to square root of 5 at angle negative 26.57 degrees raised to 10. So using de MOIVRE'S theorem, this will be square root of 5 raised to 10 at angle 10 multiplied to negative 26.57. So if we evaluate that one, you will now have your 5 raised to 10 over 2, that is 5 raised to 5, then 10 multiplied to negative 26.57, that is negative 265.7. So si theta natin, isi-simplify natin into lowest term. So let's say you have negative 265.7 plus 360, that is equivalent to 94.3 degrees. So instead of using this one, you have the value of R as 5 raised to 5, which is 3,125. So our z raised to 10 is equivalent to 3,125 at angle 94.4 or 94.3. So this is in polar form. So let's say in rectangular form, you will now have negative 234.31 plus 3,116.2 I, and that is 2 minus I raised to 10. Next example, example number 3, you will have the quantity of negative 3 plus 2I raised to 14. So we will convert negative 3 plus 2I into polar form. So getting the R, you will have negative 3 squared plus 2 squared, and that is equivalent to square root of 13. And the theta is arctan of 2 over negative 3, which is negative 33.69. But the location of your angle is second quadrant. So you have to convert the angle na kung saan manggagaling siya dapat sa positive x-axis. So para manggaling yung angle natin sa positive x-axis, the negative 33.69 must be added to 180 degrees. So our real angle for the polar form, you will now have 146.31 degrees. So our polar form of negative 3 plus 2i is square root of 13 at angle 146.31. Now we will use the MOIVRE'S theorem, which is z raised to 14, and that is equivalent to square root of 13 at angle 146.31 degrees raised to 14. So magiging square root of 13 raised to 14 at angle 14 multiplied to 146.31. So that will be 14 over 2, that is 13 raised to 7 at angle 2048.34. So simplify ulit natin si angle. Angle is 2048.34 minus 6 times ni 360. That is equivalent to negative 111.66. So ngayon, the R, which is 13 raised to 7, that is equivalent to 62,748,517. So our Z raised to 14 is equivalent to 62,748,517 at angle negative 111.66, wherein this is equivalent to polar, or rather rectangular form, that is negative 23,160,352.77 minus 58,317,874.15 I. Next example, in the MOIVRE'S theorem, you will have negative 4 minus 3i raised to 6. Ganun ulit. Kukunin natin yung polar form. So we will get the value of r, which is the square root of negative 4 squared plus negative 3 squared, which is equivalent to 5. Then the theta is arctan of negative 3 over negative 4, that is equivalent to 36.87. But the location of your theta is 4th quadrant. So kukunin natin yung angle from the positive x-axis, that is 36.87 minus 180 degrees, equivalent to negative 143.13. So our polar form is 5 at angle negative 143.13. So gagamitin natin yung de Moivre's theorem, which is z raised to 6 equals the quantity of 5 angle negative 143.13 raised to 6. So this can be 5 raised to 6 at angle 6 multiplied to negative 143.13. So that will be 5 raised to 6 at angle negative 858.78. So the angle will be simplified. So negative 858.78 plus twice ni 360, that is 82.44. So si R, which is 5 raised to 6, that is 15,625. So our Z raised to 6 is 15,625 at angle 82.44 degrees. So the equivalent rectangular form of the Z raised to 6 is 2,055.69 plus 15,489.18 I. Next topic is all about the roots of a complex number. So how will you get the roots of a complex number? So let's say you were given z raised to n equals to a complex numbers, which is a plus bi. So wherein n is considered to be the number of the roots. So if you have say squared, so automatically you have 2 roots of the complex numbers. So if you simplify the equation, you will now have z equals the quantity of a plus bi raised to 1 over n. So para makuha mo yung roots ng complex numbers, we will use the de Moivre's theorem, wherein the rectangular form will be converted into polar form. So a plus bi will be converted into r at angle theta. Then naka-raise siya sa 1 over n. So para ma-evaluate, you will now have z equals r raised to 1 over n at angle theta over n. So this is considered your principal root or the first root of the equation. Now to get the other roots of the equation, syempre, yung n hindi lang naman 1 yung value, it can be 2, 3, and so on. So nakadepende yun kung ilan yung magiging roots ng equation. So to get the other roots, you will now have z equals r raised to 1 over n at angle of the quantity theta plus 360k all over n. So, hindi magbabago yung magnitude, which is r raised to 1 over n. Ang nagbabago lang is the angle of the z, wherein k can be 1, 2, 3, and so on. So, mag-stop lang tayo dun sa n minus 1 or mag-stop lang tayo dun sa kung pang ilang roots yung hinahanap. So, syempre, for example, you have z squared, so you will have two roots. First root is your principal root, then the second root is wherein k is equal to 1. Now, let's go to the example para mas madali siyang intindihin. So, you will have your example. We will find all the roots of the equation. So, let's say you will have z cubed equals I. So, to evaluate that, you have 3 roots since n is equal to 3. So, first, find the value of r of the complex number I. So, you will have 0 squared plus 1 squared equivalent to 1. And the theta is the arctan of 1 over 0, which is equivalent to 90 degrees. So, ang polar form niya is 1 at angle 90, which is equivalent to z cubed. So, we will find 3 roots. So, finding roots, you have z1 or the first root. You will have the quantity of 1 at angle 90 degrees raised to 1 over n, which is 1 over 3. So, evaluating that, you will have z1 equals 1 raised to 1/3 at angle 90 over 3. So, you will have z1 is equivalent to 1 at angle 30 degrees. So, this is considered your principal root. So, hanapin natin yung ibang roots. Since nakahanap na tayo ng isa, ang kailangan na lang natin ay dalawa since we do have to find 3 roots. So, k is equal to 1. So, that's the second root, which is 1 at angle the given theta or the solve of theta, which is 30 degrees, plus 360. Then the value of k is 1 over n, which is 3. So, that will be z2, 1 at angle 150 degrees, and that is our second root. Then the third root or the last root of the equation, which is k equals 2, you will have z3 equals 1 at angle 30 degrees plus 360 k, which is 2 over n, which is 3. Then the value of your third root is 1 at angle 270 degrees. Next example, example number 2. Let's say you have z raised to 4 equals 1 plus I. So all we need to do is find 4 roots of the equation. So first, convert 1 plus I into polar. You will have r equals 1 squared plus 1 squared, which is equivalent to the square root of 2. Then the theta will be equivalent to arctan of 1 over 1, which is 45 degrees. So z raised to 4 equals the square root of 2 at angle 45 degrees. So finding roots, which is the principal root or what we call the z1, that is the quantity of square root of 2 at angle 45 degrees raised to 1/4. So evaluate natin ngayon si square root of 2, that is equivalent to 2 raised to 1/2. Then si square root of 2, naka-raise pa siya ngayon kay 1/4 at angle 45 degrees all over 4. So, if we evaluate this part, this will become 2 raised to 1 over 8. Then the angle is 11.25. So, our z1 is 8 root of 2 at angle 11.25, or which can be considered as our principal root. Then the other roots, let's say k is equal to 1. z2 is equal to the 8th root of 2 at angle 11.25 plus 360 degrees. K is 1 all over n, which is 4. The equivalent of your z2 is 8 root of 2 at angle 101.25 degrees, and that is our second root. Now next is the third root wherein k is equivalent to 2. You will now have z3 is equal to 8th root of 2 at angle 11.25 plus 360 degrees multiplied by k all over n, which is 4. Now the value of your z3 is the 8th root of 2 at angle 191.25, which is considered to be your third root. And the last and final root, which is k is equal to 3, you will have z4 equals the 8th root of 2 at angle 1 or 11.25 rather plus 360 degrees, wherein k is 3 and n is 4. Now the value of your z4 is the 8th root of 2 at angle 281.25, which is considered to be your fourth root. Now let's go to the next topic, which is the trigonometric and the hyperbolic function of a complex numbers. Now we will do some formula na kailangan kabisaduhin. That is the trigonometric of the complex number and the hyperbolic of the complex number. Tapos magkakaroon siya ng equivalent kasi hindi natin may evaluate yung trigonometric na ang angle ay complex number. So, kailangan mailabas natin si I bago natin i-evaluate yung equation. So, if you will have the trigonometric of a complex number can be sine, cosine, and tangent wherein yung angle mo is complex number, pwede natin siyang palitan ngayon ng equivalent hyperbolic function para mawala yung complex number sa loob ng function or dun sa mismong angle. So let's say if you have sine of BI, that is equivalent to I, then the hyperbolic sine of B. Then if you have cosine of BI, that is equivalent to hyperbolic cosine of B. Then kapag tangent of BI, that is equivalent to I, hyperbolic tangent of B. Ngayon, pagdating naman sa hyperbolic function of a complex number, mababaliktad lang. Mapapalitan lang siya ngayon ng trigonometric function. Then, same nung kanina, ilalabas natin yung I pagka na kay sine at tangent. Tapos, mawawala yung I pagdating kay cosine. So, for example, you have the hyperbolic function of the BI or the hyperbolic sine of BI that is equivalent to I, then sine of B. Then the hyperbolic cosine of BI, that is equivalent to cosine of B. Then if you have the hyperbolic tangent of BI, that is equivalent to I tangent of B. But take note that before you put in the values on your calculator, make sure that your calculator is in radian, not in degrees. Bago nyo mo muna computein yung magiging equivalent equation. Kasi kapag naka-degrees, mamamali yung sagot. So, dapat naka-radian yung calc nyo. So, let's put in sa example. Let's evaluate the given expression. So, let's say you have z is equal to cosine of the quantity 2 plus 3i. So, gagamitin natin ngayon yung trigonometric identities, which is the cosine of the a plus or minus b. This is equivalent to cosine of a, cosine of b. Then kapag plus yan, magiging minus. Kapag minus naman yan, magiging plus. Then the sine of a and sine of b. I-apply ngayon natin to dun sa cosine of the 2 plus 3i wherein a is equal to 2. Then our b is equal to 3i. So, gagamitin natin yung formula. You will now have cosine of A, which is 2, cosine of B, which is 3i. Since this is positive, it will be negative. Then sine of A, then sine of B. Now, if you will notice, si cosine 2, wala tayong problema kasi hindi complex number yung angle niya. Pagdating naman kay cosine 3i, ito yung sinasabi natin na ang angle niya is complex number. Then sine 2, walang problema yan kasi hindi complex number yung 2. Then pagdating kay sine of 3i, nandun yung complex number na angle. So let's evaluate your equation. You will now have cosine of 2 remain or retain. Then the cosine of 3i, that is equivalent to hyperbolic cosine of 3. Then minus sine of 2. Then the sine of 3i is equivalent to I hyperbolic sine of 3. Then saka ngayon natin i-input sa calcu, wherein cosine 2 is equivalent to negative 0.4161. Then the hyperbolic cosine 2 is equivalent to 3.7622. Then our sine of 2 is 0.9093. Then our hyperbolic sine of 3 is 10.0179. All these values, kailangan nakarad yung calculator. Then i-apply natin siya ngayon dito sa equation na to. You will now have negative 0.4161 multiplied to 3.7622 minus 0.9093 multiplied to 10.0179 multiplied to the I. Then, pag multiply natin tong dalawa, you will now have negative 1.57. Then this 2, you will now have negative 9.11. So, the equivalent value of the cosine of 2 plus 3i is negative 1.57 minus 9.11i. So, let's go to the next example. Let's say you have, say, equals sine of 1 minus I. We have the trigonometric identities of the sine of a plus or minus b, that is equivalent to sine of a cosine of b plus or minus cosine of a sine of b. So kung plus to, dapat plus yung nasa gitna. Then kung minus yan, dapat minus yung nasa gitna. Then identifying the a in our equation, that is 1. Then the b is I. So i-apply natin ngayon yung trigonometric identities. You will now have sine of 1 cosine of I, since that is minus yung nasa gitna natin. So you will have cosine of 1, then sine of I. Ngayon, ito yung may complex number, the cosine of I and the sine of I. Now we will evaluate the equation as is sine of 1, then cosine of I is equivalent to hyperbolic cosine of 1. Then cosine of 1, then the sine of I is equivalent to I hyperbolic sine of 1. Then inputting the values sa calculator, sine of 1 is 0.8415. Hyperbolic cosine of 1 is 1.5431. Then cosine of 1, that is 0.5403. Then hyperbolic sine of 1, that is 1.1753. Again, if you input yung value sa calcu, dapat nakarad si calculator. Then, i-apply ngayon natin siya doon. You will now have 0.8415 multiplied to 1.5431 minus 0.5403 multiplied to 1.1752 multiplied to I. Now, we will now have this 2 will result 1.30. Then this 2, ang magiging kakalabasan ay 0.63. So our z, which is equivalent to sine of 1 plus I, is now 1.3 minus 0.63 I. Now, the last topic for this session is all about the natural logarithmic function of the complex number, or what we call the ln of the complex number. So let's say you were given the ln of a plus bi, wherein a plus bi is your complex number. So syempre, hindi pa din siya may evaluate rekta sa calculator. So you need to evaluate it first bago ka gumamit ng calculator. So kapag naka-rectangular to, kailangan i-convert natin into exponential form. Hindi na siya ngayon sa polar form. So you need to get the exponential form of your complex number. Ngayon, yung exponential form is r e raised to theta I. But take note that your theta must be in radians. So kapag naka-polar tayo, degrees yung ginagamit natin. Pero kapag naka-exponential form tayo, dapat naka-radian yung theta natin. So applying the property of the natural logarithm, if you have ln of the product of AB, it can be equivalent to ln of A plus the ln of B. Ngayon, si R yung gagawin nating A, then si E raised to theta I, that is your B. So pag-iwalayin natin, it can be ln of r plus the ln of e raised to theta I. But take note that another property of the natural logarithm, if you have ln of e raised to a, it can be equivalent into a only. Mawawala ngayon sa ln at si e. So i-apply natin siya ngayon dito sa ln of e raised to theta I. So ang magiging equivalent natin, yung ln of a plus bi natin can be rewrite into ln of r plus the theta I. So let's put it in an example. So let's say you were given z equals ln of the quantity 5 plus 4i. So kailangan naka-exponential form. So you need to get the r, which is equivalent to the square root of 5 squared plus 4 squared, which is 6.4. Then our theta is arctan of 4 over 5, which is 38.66, which is located at the first quadrant. So all we need to do is to convert yung 38.66 into radian multiplied to pi over 180. So the equivalent radian angle is 0.6747 rad. So our exponential form is the r, which is 6.4 multiplied to e raised to the theta, which is 0.6747 multiplied to I. Then applying yung ln of r plus theta I, you will now have ln of 6.4 plus the theta, which is 0.6747 multiplied to I. Now evaluating your ln of 6.4, that is 1.8563 plus your 0.6747i, and that is now your equivalent value for the ln of 5 plus 4i. Now another example is ln of the quantity 6 minus 8i. So getting the r, you will have the square root of 6 squared plus negative 8 squared, that is equivalent to 10. Then our theta is arctan of negative 8 over 6, which is negative 53.13, which is located at the fourth quadrant. So as is yung angle, all we need to do is to convert into radian. So you will now have negative 53.13 multiplied to pi over 180. That is negative 0.9273 rad. So applying dun sa ln of the complex number, that can be ln of the r, which is 10, then e raised to theta, which is negative 0.9273 multiplied to I. Then i-apply natin ngayon ulit yung ln of r plus theta I. Now this can be ln of 10 minus 0.9273 I, wherein the ln of 10 is 2.3026, then minus 0.9273. So that is the equivalent value of your ln of 6 minus 8i. Now, i-apply natin ngayon yung mga topic na yon sa complex numbers raised to another complex numbers. Now, what if your equation is complex number na naka-raise ulit sa another complex number? Paano natin siya ngayon iti-treat? Kasi the previous lesson or the previous topic is just the trigonometric, hyperbolic, then the natural logarithm of the complex number. Now, if this is the case, all we need to do is this. So let's say you have the given z equals 4 minus 3i raised to 2 plus 3i. So a complex number raised to another complex number. So let's say you have to take the ln or the natural logarithm of the both side of the equation. So you will now have the ln of z equals the ln of the 4 minus 3i raised to 2 plus 3i. So alam natin that the property of the natural logarithm, kapag yung angle ng ln natin ay may exponent, yung exponent na yan pwede nating ibaba sa harap ng ln. So pwede nating ibaba si 2 plus 3i sa harap ni ln. So we will now have 2 plus 3i multiplied to ln of the angle ng ln, which is 4 minus 3i. So ito, pwede nating i-evaluate ngayon si ln of 4 minus 3i. So now let's evaluate. Kukunin natin si r, which is 4 squared plus negative 3 squared, which is equivalent to 5. Then our theta is arctan of negative 3 over 4, equivalent to negative 36.87. And that is fourth quadrant. So as is yung angle natin, all we need to do is to convert into radian, which is negative 36.87 multiplied to pi over 180, and that is negative 0.6435 radian. Now, i-apply ngayon natin to. You will now have ln of r e raised to theta I, which is ln of 5 e raised to negative 0.6435 I. Kaya lang nakamultiply siya ngayon kay 2 plus 3i, which is equivalent to ln of z. Then, i-apply natin yung ln of r plus theta I. You will now have ln of 5 minus 0.6435i multiplied to 2 plus 3i. That is equivalent again to ln of z. Then, pag multiply natin ngayon yung complex number na 2 plus 3i, then another complex number of ln of 5 minus 0.6435, wherein the ln of 5 is 1.6094. So pag minultiply natin sila, you will now have 2 multiplied to 1.6094 plus 2 multiplied to negative 0.6435i plus 3i multiplied to 1.6094 plus 3i multiplied to negative 0.6435i. And ang kalalabasan per term, that is 3.2188 minus 1.2870i plus 4.8282i. Then yung last term, that is negative, supposed to be, kaya lang I squared is negative 1, so negative 1 multiplied to negative is positive. Then kapag multiply mo si 3 sa 0.6435, that is 1.9305. So pagsasamahin natin ngayon yung real number and complex number, magiging equation natin ngayon is 5.1493 plus 3.5412i. But that is equivalent to ln of z. Ang kailangan natin is just the value of the z. So we will take the e of the equation of the both side. So you will now have e ln of z equivalent to e raised to 5.1493 plus 3.5412i. So ang mangyayari, e raised to ln of z, magiging z na lang siya. Tapos since pwede natin itong paghiwalayin with the same base, ang mangyayari is e raised to 5.1493 multiplied to e raised to 3.5412i. If you will notice, this is in the form of exponential. Kasi ito yung r, which is e raised to 5.1493. And our theta is 3.5412. Bakit hindi magiging theta si 5.1493? Kasi wala naman siyang kasamang I. So this is considered to be a real number, or the R of the equation. So e raised to 5.1493 is equivalent to 172.3108 multiplied to e raised to 3.5412i. So si theta na 3.5412i, this is rad. So, i-convert natin into degrees, multiplying it to sa 180 degrees all over pi, that is equivalent to 202.8958. So, if we simplify the theta, the minus 360, our original theta for the polar form is negative 157.1042. So, the polar equivalent is 172.3108 at angle negative 157.1042. Now, let's find out the rectangular equivalent of this equation. So, hanapin natin si A, which is 172.3108 cosine of the angle negative 157.1042. That is equivalent to negative 159.6599. Then finding the value of B, that is 172.3108 sine of the angle negative 157.1042. That is equivalent to negative 67.4193. Now, our rectangular equivalent is negative 159.66 minus 67.42i. I. And that is the equivalent equation or the equivalent value of the given expression 4 minus 3i raised to 2 plus 3i. Next example, let's say you have z equals 2 at angle 30 degrees raised to I. So again, we will take the ln of the both sides. So you will now have ln of z equals the ln of 2 at angle 30 degrees raised to I. So ibababa ulit natin si I kasi exponent siya nung angle ni ln. So this can be ln of z equals I multiplied to ln of 2 at angle 30 degrees. So si 2 at angle 30 degrees will be converted into exponential. So yung 30 degrees natin, i-convert natin into radian, which is equivalent to pi over 6. So magiging ln of z equals I multiplied to ln of 2 e raised to pi over 6i. So i-apply natin si ln of r plus theta I. That can be ln of 2 plus pi over 6i multiplied to I, equivalent to ln of z. So ln of 2 is 0.6931 while pi over 6 is 0.5236 multiplied to I. So ang mangyayari, ln of z now is negative 0.5236 plus 0.6931. So ito, magkakaroon ng I, magiging imaginary. So I multiplied to I, that is negative 1 multiplied to this. So yun ngayon yung magiging real part natin. So kukunin natin yung E of the both side para mawala yung ln since ang kailangan natin ay only z value. So e raised to ln of z equals now sa e raised to negative 5.236 plus 0.6931i. Pag ihiwalayin natin ngayon yung e nung kabilang side, it will become e raised to negative 0.5236 multiplied to e raised to 0.6931i, and that is now equivalent to z kasi makakancel na ngayon si e raised to ln. So ganun ulit, this is exponential form. This one is yung may theta I, wherein theta is 0.6931. Then since this one doesn't have any presence of I, it will become your R value. So ang magiging equation mo na ngayon is 0.5924, then e raised to 0.6931. Then si theta na 0.6931 rad, i-convert natin into degrees by multiplying sa 180 over pi, that is now equivalent to 39.7117 degrees. So ang magiging equation na natin ngayon in polar form is 0.5924 at angle 39.7117. So all we need to do is to find the value of A and B para mahanap natin yung rectangular equivalent ng equation. So finding A, you will have 0.5924 cosine of 39.7117. That is equivalent to 0.4557. Then for the B, that is 0.5924 sine of 39.7117. That is equivalent to 0.3785. So our rectangular value for the equation given, that is 0.46 plus 0.38i. And that's it. So thank you for watching and listening for this session. I hope you learned a lot in this session. So see you again. Thank you and God bless.